What if I told you that ancient engineers, without electricity, cranes, computers, or even steel tools, built faster, more systematically, and often more durably than we do today? It sounds impossible, yet the proof still stands everywhere in Europe. Roman roads, aqueducts, amphitheaters, and entire cities, constructed 2,000 years ago, continue to survive, while many of our modern structures crumble in just decades. The secret of Roman engineering was not magic nor superhuman strength. It was something far more powerful: standardization plus military-grade organization. Rome turned construction into a fully optimized machine. Every brick, pipe, road width, camp layout, and construction tool was standardized. Every legionary was trained not only to fight, but to build with military precision. The Roman miracle began with something incredibly simple: identical measurements throughout the empire. The Roman foot, palm, cubit, pace, and the famous milla passuum, or 1,000 paces, became the universal system. A plan drawn in Rome could be executed in Britain, Syria, or Carthage with zero reinterpretation. This alone saved months of recalculation and eliminated mistakes that crippled other ancient civilizations. Roman bricks were standardized too. Factories across the empire produced bricks of the same size, the same shape, stamped with the same legion or workshop mark. If a legion needed to build a fort, an aqueduct, or a wall, they already had the components, like Lego blocks of the ancient world, ready to assemble. And what about the tools? A Roman soldier carried the dolabra, a hybrid of axe and pickaxe, universally issued to every legionary. That meant any military unit could instantly transform into a construction crew without waiting for equipment to be delivered. This alone explains how Rome built fortified camps in a single afternoon. Yes, every evening after marching, the legions did something that terrified their enemies. They turned raw terrain into a fortress. Not tents, not a temporary stop. A fully fortified, rectangular, military-grade city with trenches, ramparts, palisades, gates, streets, and zones for officers, soldiers, storage, and animals. And they did it in 3 to 6 hours, no matter how exhausted they were. But how? The secret was division of labor. Surveyors ran ahead, marking exact camp boundaries with flags. One group dug the trench, another piled earth to form the rampart, another hammered stakes into the palisade. Others set up tents, organized tools, built fire pits, and prepared watchtowers. A well-trained legion was not just a fighting army. It was the world's largest mobile construction corporation. And then there was concrete. Roman hydraulic concrete, opus cementitium, has baffled modern scientists for decades. While modern concrete cracks under seawater, Roman concrete grows stronger. Why? Because of volcanic ash, pozzolana, mixed with lime. This combination created a self-healing mineral reaction that allowed harbors, bridges, and aqueducts to survive not decades, but millennia. This concrete enabled arches, vaults, domes, and multi-level structures impossible in earlier civilizations. The Pantheon Dome still stands after 1,900 years. Modern engineers admit they still cannot recreate it perfectly. And then came the aqueducts, the arteries of Rome. Massive channels of stone and concrete transported clean water from mountains into cities, sometimes from 80 kilometers away. the real genius, the slope. Aqueducts had a drop of only a few centimeters per kilometer, an engineering precision that even modern teams struggle to match. Most of the aqueducts were hidden underground. But when valleys appeared, Rome didn't go around them. They built monumental arches to cross them perfectly straight. This level of confidence, we reshaped the landscape, not the other way around, defined Roman engineering. But if the Romans were masters of water, they were absolute gods of roads. Straight roads that cut through forests, swamps, hills, even mountains. Legionaries removed vegetation, dug a deep trench, laid foundations of stones, gravel, crushed bricks, and finished with massive stone slabs, perfectly aligned. These roads were built to survive weather, erosion, heavy carts, and millions of footsteps. Not for comfort, not for trade, but for one reason: rapid military movement. Rome conquered the world by marching faster than anyone alive. But none of this brilliance would have worked without one more ingredient, the most important of all, a secret even more powerful than concrete: the Roman system of mass labor organization. In part 2, we uncover how Rome coordinated tens of thousands of men, moved millions of tons of materials, and built megastructures like the Colosseum faster than modern nations with cranes and computers. The miracle behind Rome's construction speed was logistics, a vast, empire-wide supply chain unmatched until the industrial age. Rome possessed state-owned quarries, forests, brick factories, and transport fleets. When the emperor wanted to build something, he didn't hire contractors. He mobilized an entire empire. Stone traveled by river, marble traveled by sea, timber traveled on ox carts. Bricks and tools came from factories owned by the legions themselves. Every major project, road, bridge, aqueduct, amphitheater, had a dedicated workforce. Each team specialized. Some dug, some carved stone, some mixed concrete, some built scaffolding, some operated cranes, some hauled materials. This was not random labor, it was a human machine. The best example of Rome's organizational genius stands in the heart of the city, the Colosseum. A building so gigantic that modern architects still struggle to explain how it was completed in only 8 to 10 years. The answer? Standardized modules, assembly line construction, and thousands of workers divided into synchronized sectors. While one team built arches in the north, another built arches in the south. While carpenters shaped the wooden frames for the vaults, masons carved travertine, crane operators lifted blocks, and concrete workers poured the underlayers. Roman cranes, powered by men walking inside giant wheels, could lift several tons, enough to build upper tiers with impressive speed. Below the arena, the high podium, a labyrinth of elevators, cages, tunnels, was a masterpiece of mechanical engineering. Platforms lifted animals, scenery, and gladiators into the arena with theatrical timing. The entire underground system was built after the main structure, proving that Roman construction was not only fast, but incredibly flexible. Aqueducts required even more precision. Surveyors measured angles with the diopter and water levels with the chorobates. They dug straight tunnels through mountains, sometimes approaching from both sides and meeting perfectly in the middle. This required mathematics, patience, and above all, discipline. And everywhere, the same pattern appears. Thousands of men working like a machine, all following the same standards, using identical tools, guided by uniform training. This brings us to the heart of Roman engineering, the legionary himself. He was not just a soldier, he was a builder, carpenter, mason, surveyor, blacksmith, and laborer. In peacetime, legions built roads, temples, bathhouses, ports, and fortresses. A legion could build an entire city faster than many modern nations can build a highway. Their discipline was military. Their organization was mathematical. Their tools were simple, but their system was perfect. Roman engineers understood a truth. Modern civilization often forgets. A great project does not require advanced machines. It requires a great system. Rome's buildings endure because they were made with smart materials, standardized tools, organized labor, consistent measurements, and discipline stronger than steel. Where modern projects collapse under bureaucracy, Rome thrived on clarity and order. They built not for decades, but for eternity. 2,000 years later, their aqueducts still carry water. Their roads still guide modern highways. Their amphitheaters still stand tall. Their concrete still defies the ocean. And their legacy still shapes our understanding of engineering. If you want more journeys into the forgotten brilliance of ancient civilizations, from Inca stonework to Greek mechanics, leave a comment and subscribe. The ancient world still has secrets waiting to be revealed.